Good morning, all. Today we will discuss the gyroscopic couple problem. We will solve one or two problems from the gyroscopic couple. Now, shall we start? Yes. I hope you all are seeing this presentation. In earlier classes, we have discussed the precessional angular motion and the gyroscopic couple and the vector diagrams and what is the axis of spin, what is the plane of spinning, what is the axis of precession, what is the plane of precision and the axis of active gyroscopic couple and axis of reactive gyroscopic couple and plane of gyroscopic couple. Now we will see a uniform disc of diameter 300 mm and of mass 5 kg is mounted on one end of an arm of length 600 mm. The other end of the arm is free to rotate in a universal bearing. If the disc rotates about the arm with a speed of 300 rpm clockwise, looking from the front, with what speed will it process about the vertical axis? The vertical axis. In last class, we have discussed this vertical axis OY is called axis of precision. The axis of spin OX, as you observed, the axis of spin OX is rotating in the plane of precision which is horizontal about this axis of precision. So OX is rotating in the plane of precision about the axis of precision at some angle delta theta. Coming to given data, the given data in the problem he has given, the diameter of the disc is 300 mm. That means the radius of the disc is 150 mm. That converted into meters, 0.15 meter. And mass of the disc is mentioned 5 kg. And length of the arm, the disc is mounted on arm. And the length of the arm is 600 mm. That means 0.6 meter. And the speed of the disc is 300 rpm. And we can write omega equal to angular velocity omega equal to 2 pi n by 60. That means 2 pi n into n means 300 by 60. We will get 31.42 radian per second omega linear velocity. As we know that the mass moment of inertia of the disk about an axis through its center of gravity and perpendicular to the plane of the disk, I equal to the mass moment of inertia of the disk I equal to mr square by 2. M is mass of the disk and r is the radius of the disk. So by substituting the mass and radius of the disk in mass moment of inertia I equal to mr square, we will get 0.056 kg meter square. The units for the mass moment of inertia is kg meter square. And the unit of the couple is Newton meter. Okay, then we will go to couple due to mass of the disk. The empirical theoretical formula. the couple due to mass of the disk C equal to mgl. M is the mass of the disk, G is the gravitational force, and L is the length of the arm. By substituting the mass, gravitational force, and length of the arm, we will get couple due to mass of the disk C equal to 29.43 Newton meter. Now let omega P, consider omega P is the speed of the precision, the angular speed of the precision. And we know from the gyroscopic couple concept, the gyroscopic couple C equal to the product of mass moment of inertia and lean angular velocity of the disk initially and the angular velocity of the disk, precessional angular velocity of the disk when the axis of spin is rotate in the plane of precision about the axis of precision. Okay, by substituting the mass moment of inertia I in this formula, in this problem, we got mass moment of inertia I equal to 0.056. And substitute omega. Omega we have found omega 2 pi n by 60, that is 2 pi n into 300. 2 pi into 300 by 60, we get 31.42. And omega p, we don't have omega p, but we have couple C, empirical formula couple C due to mass of the disk. So by substituting 29.43 equal to, that is couple C, 29.43 due to mass of the disk equal to I omega omega p. Here C we know, I we have found out earlier, and omega we know. Finally, we will get omega p. The value of omega p is 29.43 by 1.76, that is 16.7 radian per second. Here the important concept is whatever we have learned in gyroscopic couple concept. The gyroscopic couple C equal to product of mass moment of inertia and the linear velocity, the angular velocity of the disk omega and precessional angular velocity of the omega. And in this problem, we have observed the empirical formula of the couple due to mass of the disk C equal to mgl. If we know mass of the disk and length of the arm, we will get the couple due to mass of the disk, and we will substitute the couple formula. We will get the value of omega p. I we have in this problem mass moment of inertia, and omega we have, and we don't have omega p. That is the value to be observed, value to be calculated or solved. So finally, we got omega p, precessional angular velocity omega p equal to 16.7 radian per second. And we will see in next class, we will solve another problems. And we will go through few concepts on gyroscopic couple effect, the effect of gyroscopic couple on different cases. Thank you very much. Thank you for joining the session.